In this video, we're going to use the Python library called Numpy. So first, let's import Numpy. Now we can see a vector here. So let's create a vector using Numpy. So we'll use the np.array function, and then we'll pass in the parameters we're giving. So here, vector is a one-dimensional array. Now let's create a matrix. Here, this is a 3 into 3 matrix, so it is very easy to create it. Okay, wait. We'll print this first. Let's see the. Okay, so this is the array we have created. Now let's create a matrix. So it's the same function, but instead of giving all the numbers in a line, we'll give all the numbers which are in the same row in one bracket and separate it. Okay, so I'm going to write it in 3 different rows, so it's easier to see and understand, but you can also write the whole code in one line. So in the first line, we have 5, 3, and 8. In the second row, we have 19, 12, and 4. And in the third row, we have 25 and 10. Okay, so now let's print it. So here we have created a 3 into 3 matrix. Okay, so now we are going to add 2 arrays. So here I've got the vector 1, which is an array of 1, 2, 3, and I've got another vector 2, which is an array of 4, 5, 6. So now we'll add both the vectors. So here we have element-wise addition of the vectors. Subtraction is also easy. Instead of this, I can just do subtraction and I'll get the answers. And multiplication, element-wise multiplication, I can just do v1 into v3. And you've got the multiplication. The matrix is also similar. So here I have matrix 1, which is 1, 2, 3, 4, 5, 6, and 4, 5, 6, a 3 into 3 matrix. And then I've got another matrix 2. Wait, I've got printed here. Okay. And then I'm adding the matrix 1 and matrix 2 together. So this is my matrix 1. This is my matrix 2. And this is the sum of matrix 1 and matrix 2. And subtraction you can do in a similar way. So this is the answer, my m1 minus m2, and even multiplication. And this is element-wise multiplication, not the product of matrices. The product of matrices we'll do next. So this is element-wise multiplication. So here this is like 1 into 3, 4 into 2, 5 into 3, 4 into 6. So it is like the elements of M1, the first row and the first column by the first row and the first column of the second matrix. The second row, second column by second row, second column. This is not the dot product multiplication which we have. Okay, we'll do that next. So this is how we do addition, subtraction, and multiplication. Even division we can do the similar way. So if we do v1 by v2, we get the division of the full v1 array and v2 array. And similarly, if we do m1 divided by m2, we have element-wise multiplication over here. Similarly, we can also do scaling. So I can do 6 into v2. So here I'll have 6 multiplied by all elements of v2. So 6 4s are 24, 6 5s are 30, 6 6 are 36. And similarly, I can also do scaling of matrices, which is 5 into m2, for example. And then I'll get 5 into 3, 15, 5 into 4, 25 into 5, 25. So for each element of m2, we're going to multiply it by 5 and we'll get the results here. Okay. Now, like we scale, we can also change it into addition. So if we do 6 plus v2, every element of v2 will add 6 to it, and we can also do 6 minus v2, and every element of v2, 6 will be subtracted from it. Similarly, for matrices, we can do 5 plus m2, and for all element in m2, 5 will be added to it, and 5 minus m2. For all elements in m2, 5 will be subtracted from it. So now let's find the dot product of the vector 1 and vector 2. So for this, we use the np dot function of v1 and v2. So we'll save this in a variable called v4. Okay, so now let's print v4. So here 32. So 32 is the dot product of the vector 1 and vector 2. Okay, so now if we want to find the product of the matrices, like earlier we found the element-wise multiplication of the matrix, now we're going to find the product of matrices, like the mathematical multiplication of the matrices. So we'll use the at function. So we'll give m4 is equal to m1 into m3. No, sorry, m2, and then we'll print the m4. So this is the product of matrix m1 and m2. So now we'll find the transpose of the matrix. So first let's get the m1 matrix. So now to find the transpose of this matrix, transpose is when you exchange the rows and columns. We just have to use m1 dot t function. So now we can find the matrix. So to find the shape of the matrix, we can use the shape function. So this is a 3 to 3 matrix and m1 dot transpose. So this is also 3 to 3 matrix. Okay, so now we're going to create an NP array which has zeros in it. So x is equal to np dot zeros. And here we have to give the dimension. So if I just want one array which has like just 3 elements in it, I'll give 3 and let me print it out. Okay, so here we've got 0, 0, 0. All these values are, all these elements are in float. Now instead if I want a 2D array which has 3 rows and 2 columns in it, I'll have to add a bracket before mentioning the dimensions, and then 3, 2. Okay, so there are 3 rows and 2 columns. Now if I want a 3D array which has 3, 2, and then 5, 4. So here I've got a 3D array. Now if I want only ones in it, instead of zeros, I want ones. I'll just do an np dot ones. And so here I've got ones instead. Okay, so now we're going to learn about reshaping an array. So suppose we have an array which has 8 elements in it, like for example. Okay, so this is a 1D array with 8 elements in it. So let's check its shape. Sorry. So it has 8 elements in it and it's in a 1D array. So now if I want to reshape it to have like 4 columns and 2 rows. Okay, so I want 2 rows and 4 columns. Then I can use the reshape function and I've got a new array which has 2 rows and 4 columns in it. Now if I want to reshape it in a way, I want 4 rows, but I don't want to specify the number of columns. That the numpy can decide. Then I can use a.reshape. So I want 4 rows, but the number of columns is up to numpy. Then I can use the -1 function. -1 is like an unknown number. So it is up to the numpy to decide. So if you give it like this, so we got an array which has 4 rows and the number of columns are 2. And for example, we can also do it for the number of rows. For example, I want 3 columns. Okay, so the number of rows does not matter, but I want 3 columns. Then I will get an array. Because the number of elements we have given, we cannot form a proper array with it with just 3 elements. So instead, if I give like 2, I can have, I'll get a proper array because with 2, I can form a proper equally divided array. Or if I give 8, or if I give 4, for all these numbers, I can create a properly divided array. But if I am giving like 5 or 6 or even 7, I will not be able to create an array because 8 cannot be properly divided into 7 sets. Okay, so let's keep it at 4 here. So now to slice it, we're going to start from 0 indexing. So if I want the third row over here, which is 5 and 6, it will be the second index because there is 0 indexing. So the 1 and 2 will be 0 index, 1 will be 3 and 4 index, and 2 will be 5 and 6 index. So if I write the array's name M with 2, which is the third row, I can get 5 and 6. Now if I want just 5, or if I want just 10, then I'll have to first slice the number of rows. So the row which I want is 0, 1, 2, 3, 4, the fourth row. And the column which I want is 0, 1, the first column. So I'll write 1. So now if I run it, I'll get 10, which is the last element. So which is the fourth row and first column from 0 with 0 indexing. So similarly, you can slice the other numbers, and it is very easy. It is similar to Python indexing. Okay, so now we're going to see how we can stack arrays. So for example, if I have 2 arrays, like for example, np dot. Okay, so here I have 2 arrays. Let's see both the arrays. I have 2 arrays, 1, 2, 3, 4, and 5, 6, 7. Now I want to stack them together. So I want to make connect them. So now I want to join them together to make them one array where 1, 2, 3, 4 is on the top and 5, 6, 7, 8 is on the bottom. So I'm going to use the concatenate function. So I'm going to do np dot. So the 2 arrays which I want to concatenate. So axis equal to 0 means I want to concatenate it row-wise, and axis equal to 1 means I want to do it column-wise. So let's print and see how it goes. So here I have one array and it is stacked row-wise. Now if I want to do it column-wise, I can just change axis to 1. And here I have it column-wise. Okay, so now we're going to check out a few arithmetic operations which are there in NumPy. So first let's get the array. So this is the array which we had made earlier. So now if I do m dot sum of m, we'll get the sum of all the elements in M. But if you just want it row-wise, so we'll get the sum of each row. And if I want it column-wise, I'll get the sum of each column. And similarly, we can find the mean. So we can find the mean of the whole M array, or we can find the mean of just the column array, or just the row. Similarly, we can find the minimum value. So the minimum value in the row in each row, or we can just find the minimum value of the whole M array. And similarly, we can find the maximum value. Okay, so now we have the replace function. So here we are going to replace the elements which are greater than 4 as 1 and which are lower than 4 as 0. Okay, so we'll use the np.where function. So we want the m in which the elements which are greater than 4 to be 1, else it should be 0. Okay, so let's print m now. Okay, so here we can see the elements which are greater than 4, which is these elements, they have turned into 1, and the elements which are lower than 4, that is which is not greater than 4, have turned into 0. Similarly, we can make it like, for example, we can give it 3. So the elements which are greater than 3, or the elements which are equal to 3, we want it 1, else we'll just leave it at 0. Okay, so we have to give double equal to over here.